All right, let's talk about some important terms for machine learning, which will lay the foundation of your journey to learn machine learning as well as artificial intelligence. So first, let's talk about label. So label is the value that we are trying to predict. It is the output. So when we talk about X and Y in machine learning or the linear regression model, it is the Y. Uh, an example I would like to take here is, let's say we have a data where we have height or we are trying to predict the height of men for a particular age in country Finland. So we have a lot of data available for maybe, let's say, about more than 100k or 500k men there with their age and the corresponding height, and we would like to predict the height given a particular age. So that particular height is the label here, right? And now let's talk about feature. So a value describing the data which helps to predict the label. So in our previous example, label was height, and if we talk about the age, that will be our feature. So it is the X in our basic linear regression. Again, I've talked about X1, X2, X3 till Xn because we're not only talking about a single value against a single output. It has to be multiple so that it is acting as a machine learning model for us to give a lot of data to learn. Now here the example would be the age. So age will be the feature here. We already talked about label, which would be the height. Now, what is example? Example is the particular value of X. So 45 years, 27 years, 85 years, 70 years, all these are examples because these are the value of X against which we will be able to predict the value of Y. Given we already know a lot of data where we know X and Y, we know that, let's say, for a 25 years of age, we have 176 centimeters is the height. For 12 years of age, there is the height of almost 150 centimeter. Again, that can be one of the example, right? Labeled example. So it has both the feature and label available, like X comma Y, and it is very particularly used to train the model. Uh, it is used in supervised machine learning, especially because it's a labeled example where you would have both the label as well as the feature available. So let's say we have at least 100k labeled examples to give the height to a corresponding age of men in Finland. Maybe that starts from 1 year towards 25 years, because we know post 25 years there would not be any change in height, or let's say post 18 years. So we would like to just understand what would be the height, or we would like to predict a height of a person aged 10, and that labeled example would help us to do that. Now let's talk about unlabeled example. Unlike labeled, it does not have the label. That is, it doesn't have the Y. You only have got X, or you only have got the feature. And this is in particularly used for prediction of new data. So since you do not have a data to train the model learns by itself from the pattern. It does clustering to understand what the data looks like and does the segmentation itself. In my next video, when I talk about the supervised machine learning versus unsupervised machine learning, you will get more idea about how unlabeled example help the unsupervised machine learning, but that's what it is used for, right? Thanks for joining. I'll see you next time.